today, our goals and objectives in this block is to decide whether two quantities are in a proportional relationship by looking at a table or graph, identifying the constant of proportionality or unit rate in tables and graphs, represent proportional relationships with equations, and explain what a point X and Y on the graph of a proportional relationship means. And this is block 2 from section 3 in Agile Mind. All right, so our opening question today, I want us to look at the table and the graph of paint mixture in that overview. And so I want you to describe the proportional relationship between the blue and the yellow paint in that mixture. All right, so in the paint mixing scenario, what were the variables?
One and two.
All right, so blue paint and what?
Yellow paint.
And the yellow paint. All right, so depending on how much blue paint tells us how much what?
Yellow.
Correct.
Yellow paint.
Correct. And we said yesterday that for every 1 cup of blue paint, we could do
There's
what?
2 cups of yellow paint.
Correct.
And go back.
Correct. All right. So, as the number of cups of blue paint increased, we said that the number of yellow cups increased by two times. Good. Perfect. So, how were the ratios used in that scenario? Like, in other words, explain which each ratio means.
Why did you say how many ratios we use?
Cups of blue paint, cups of yellow paint.
Correct. Yeah. Perfect. So, for instance, if we had 2 blue, we had 4 yellow. Or 3 blue, we had
6 yellow.
Good. All right. So that's what we went over yesterday. So today we're going to be looking at page 1, starting off with this. And it says to study the pattern in the table and the graph, can you write a rule to determine the number of cups of yellow paint you will need for any number of the cups of blue paint? Write your rule in words. So I want you to think about what equation or what rule we could write that would allow us to know that no matter however many cups we have of blue paint, we would be able to find our yellow. So I want you to think about what we could do there. And that's actually going to be question 1 today in our workbook. So if you don't have your workbook out, everybody needs to get their workbook out real quick.
I still have it on my bed.
All right.
Page 64. Page 60 what? Not 64, 67.
Page 67. Good job. Page 67. Okay, so everybody should be at page 67. So let's take a look at what happens.
Oh, I get it.
That's pretty interesting, huh?
What that say, Mr. Martin?
So basically that's saying that repeated addition can also be represented as multiplication. And all this is showing us is exactly what Isamian and Halen said earlier, that however many cups of blue paint we have, we can multiply by 2. And that's what they're doing over here in this section. But they showed it by using repeated addition. So when we talked about writing a rule, they're saying that the cups of blue paint is X and the cups of yellow paint is Y. So read what that says down there for us, please, Lainey.
Relationship you describe between the number of cups of blue paint, X, and the number of cups of yellow paint, Y. These are the variables. The variables represent the things that change the situation. How is the variable X represented in the process called?
All right. So, who thinks they can come up with a way to write an algebraic rule to solve this? What could we say? What would y be equal to?
The things of yellow paint.
Correct. But what could we say to find how many cups of yellow paint we would need? And if X represents any number,
10.
somebody help Isaiah now. Y'all talk together, see what you could come up with. What did we say happens to the cups of blue paint to find the yellow paint? What's happening?
Every ounce of blue paint you're gonna have 2 times the amount of yellow paint.
Okay. So if you look here, they did 1 times 2, 2 times 2, 3 times 2, 4 times 2. So what do we need to do with this?
5 times 2.
Say it again, Jamal.
5 times 2.
All right, but this isn't a 5. This is a what?
X.
So couldn't we do? There we go. That's what I'm looking for. So it says the variable represent what changes in the process column. And so Jamal said we're going to put X here and we need to multiply it by 2 to figure out how many cups of yellow paint there are. Remember that X is just a letter that stays in place of a unknown number. Okay? So just like Jamal said, we did what? Read what that says, please, Jamal, in the yellow, please, sir.
X times 2. No, the number of cups. My bad. The number of cups of yellow paint is always 2 times the number of cups of blue paint. The 2 is I can't see this for. The 2 is the constant multiplier. It stays the same in the situation.
Perfect. So every time we're always multiplying by what?
2.
2. So that's the what?
The constant.
Good job. The constant. All right. Perfect. So this is how they wrote it. They said that y equals x times 2 or y equals 2x. So it says in the algebraic rule, y equals 2x. The 2 is an example of a coefficient. What does it say a coefficient is, Layla?
A coefficient is a value that multiplies a variable.
All right, so it's the number that we multiply by the variable. What's the variable? Who remembers what the variable is? Good job. Good job, Chandler. X is the variable. And remember that a variable is just a letter that stands in for an unknown value. Good. We getting it, guys. All right. Our next one. Let's take a look. It says you may have found the constant multiplier in a different way by thinking about a unit rate. So remember our unit rate was what?
2 yellow paint over 1 blue paint.
Correct. So 2 yellow per 1 blue. And so if we do 2 divided by 1, we get what?
1.
2 divided by 1?
Oh, 2.
2. Good. 2. So it's the same as that constant multiplier. So the constant of proportionality or the unit rate is actually going to be the same thing because 2 divided by 1 is 2 and the constant multiplier is 2 as well. All right, so what if we took 0 and multiplied it by our constant? How many cups of yellow paint would we have?
0.
Correct. So That means if we had 0 blue, we would have 0 cups of yellow. And it says the rule applies since you cannot create green paint without the blue paint.
So it'll be 2. So it'll be 0, 2.
It'd just be 0, 0. Like, because if you have 0 cups of blue paint, you're not going to have any cups of yellow paint because there's 2 times as much yellow as there is blue. All right, so it says you have created 4 different representations. How are the representations related? Discuss your observations with a partner. Well, our partner is going to be our whole class, okay? So I'm looking for all of us to kind of chime in on this. All right, so the first one we have is a table representation, then we have the graph, then we have the verbal description, and the algebraic rule. All right, so how are they related to each other? And this is question 1F in the book. We've already answered questions A through E. So what do you notice that's the same between the table and the graph?
They all mark the same numbers.
Okay. So what do we notice about the cups of blue and the cups of yellow for every one of these things?
That they all match up. Because the cups of blue to yellow, because cups of blue paint equals times 2 of cups of yellow paint. And they show that in the graph by going up in the same order as the graph that we have right up beside it.
Good. All right. And so looking at the verbal description, what Isamian said, he said to find the number of cups of yellow, we multiply the cups of blue by 2. Is that the same as the algebraic rule that we came up with, Najela?
Yes, sir.
Awesome. I want to say great job to Isamian and Najela. Our whole class was actually supposed to participate in that. But Isamian and Najela stood out. So I think everybody deserves to give them a high five or a clap. So I'm going to clap for you. Proud of you. All right. So right now, what we're going to do is I'm going to pause our video and I am going to take our roll.
Listen, my mom got no pen, so I can't write it.
Get you a pen.
Don't you got a pen like this?
There you go.
Well, what if I mess up? Just right over it.
Yeah, just draw a line through it. All right, so we are going to page 2. So if you can, would you read that for us, please, Keegan?
Now considering a different shade of green. For this shade of green, you must use 3 cups of yellow.
Hold up just a second, Keegan. Hold up just a second. Najela and Isamian, mute your mic, okay? Sorry about that. Keegan, try it again.
Now considering a different shade of green. For this shade of green, you must use 3 cups of yellow paint for every cup of blue paint. Create a table, graph, verbal description, and algebra rule for this new scenario.
All right, so I want you to do this right now. I want you to create the table, the graph, and a verbal description and an algebraic rule for this exact same question, okay? Well, I say exact. The only difference is instead of having 2 cups of yellow paint, how many cups of yellow paint do we have now?
3.
3. All right. So I want to give you about 5 minutes to see what you can get answered, okay? So I want you to do that now. So, somebody tell me what you got for your table. What did you get for your table? What did your process look like? How do we get 1 to become 3?
1 times a 3.
Good. All right. So if we have 2 cups of blue paint, how many cups of yellow paint would we have?
6.
Perfect. And what is the process to find that?
1 plus 3 plus 2. Well, no.
Wouldn't it be 2 plus 2 plus 2,
Yes.
which is 6? All right. What about for 3? What would we get?
9.
9.
Good. How are we getting 9, Sarah?
We do like 3 plus 3 plus 3.
Perfect. All right. For
Or
4,
we can like times it by 3.
perfect. Rasiah, what would we get for 4?
12, I think.
All right. So let's look at it. We would do 4 times 3. So that'd be 4 plus 4 plus 4. And does that equal 12? Yeah. Good job.
Yes, sir.
Good job. All right. So let's see how if they got the same that we did. All right. You did good. So what about if we had X? What would we do with X to figure out the cups of yellow paint? What would we need to do?
I'm going to let one of them answer.
When we multiply by 3?
Yes.
Just
It'll
like
be
they did?
on 3x, and it will be on y equals 3x.
Perfect. Perfect job. All right. Because no matter what X equals in blue paint, as long as we multiply it by 3, we would know how many cups of yellow paint we need, right?
Yes, because x is an unknown number.
Perfect. Perfect job. All right. So this would have answered question 2 and question 3 on your workbook. All right. So let's see what we get for question 4. All right. So it says compare the graphs and equations for 2 different paint mixes. Did you notice anything about the relationship between the graph and the algebraic rule that describes it? What happens? And while you're looking at this, does the graph that you made does it look like graph number 2?
No, because my graph is a little bit bigger.
Okay, but did you have it going to 1 to 3 and 2 to 6 and 3 to 9?
Yes, sir.
Perfect. All right. Did everybody see Isamian's? Isamian, hold that up.
If it can fit to the camera.
Oh, yeah. That looks great. You did a great job. All right. So Isamian's graph is showing that for every cup of blue paint, there are 3 times the amount of yellow paint. Okay. So what do you notice about the relationship between the graph and the algebraic rule that describes it? So look at graph 1. What do you notice there?
It's kind of more slanted.
It is. Yeah, it's not as steep. All right.
And
And
the
why is it not as steep?
because it's counted times 2.
Correct. So there's 2 cups of yellow for every 1 cup of blue. So why is graph 2 steeper?
Because every 1 cup of blue is 3 times the amount of yellow.
All right. Do y'all agree with him, Jamal?
Yeah, I agree with Isaiah. I would just give it a little more.
All right. Well, I couldn't hear what you were adding. Go back to it and add what you were saying.
Or like I was saying that it was lower than the green.
Correct. All right. So looking at these, which one would be the brighter green? Would it be 1 or 2?
2.
Why do you think that?
Because Jamon. Oh no, you can go. You said first. Because when we were using the graph before with because of 1 cup blue cup of paint is 2 times amount of yellow paint, it showed a dark green. So if we did the same thing with 3 times of the yellow paint, it would be a darker green. Just because
Would it be darker or would it be lighter?
It'll be darker.
All right. So if you put more yellow with the blue, what do you think, Jamal?
I think it's 1 because it's lighter. Like the numbers are lighter and stuff like that.
All right. So I want you to think about this. If we had blue and we pour 1 cup of blue and 2 cups of yellow, then it's kind of like a yellow green, right?
Yes, sir.
But if we pour 1 cup of blue and 3 cups of yellow, isn't it going to be like really yellowy green?
It's gonna be like
Yeah, so it would make it lighter. So the one that is y equals 3 times x would be a lighter green than the one that is y equals 2x. Does that make sense, Najela?
A little.
Okay. What do you think, Lainey?
Kind of.
All right. Tashandrick, restate what I just said. Or you can put it in your own words, Tashandrick. All right. So who can restate? Isaiah, you done good, man. I want to see if I can get somebody else to restate it for me. All right. Who can kind of add to what we were saying? Keegan, if you can answer this, then you can go to the restroom.
What is it?
So we were trying to explain why graph number 2 is a brighter green than graph number 1.
I don't want to just say because it's more paint, but is that like
What color of more paint?
there's more green paint?
There's more yellow. That's right. Good job, Roykia. Since there's more yellow, what happens?
It gets lighter.
It gets lighter. Yes. All right. Go ahead, Keegan. So that is on question 4. So we said, how are the graphs similar and how are they different? So they're similar is in they're both what type of relationships?
I just had this proportional.
Good. They're both proportional relationships. All right. They're different because we said that number 2 is steeper than number 1. And then it said, how are the algebraic rules similar? Well, the only thing that is, they're both in the form of y equals what times x?
2. No.
Nope. Y equals k times x is the form they're in. All right. And so remember, that is the form that we always create equations with for proportional relationships is y equals k times x. Now, the way that they're different is k the same for both of them? Is the constant the same?
No.
No. For the number 1, it's what?
It's the same.
No, for number 1, it is what number? 2. And for number 2 graph, it is what? I think we're getting confused. Good job. Remember, y equals k times x. K is the constant. All right? So the constant for graph 1 is here. The constant for graph 2 is here. And we just got that answer. Emma, was that you that said that?
Mm-hmm.
All right. Good job. So, how can you see the increase of 2 cups of yellow for every 1 cup of green in the graph? How do you see that?
You said 2 cups?
Yeah. So looking right here at this graph, every time that we go over 1, what's happening?
It goes straight up. It's getting higher. Well,
How many times does it go higher? Look, so I'm going 1 and up 2, and then I go over 1 and I go
2.
and then I go over 1 and I go up.
Can you hear me?
Yeah, I hear you every time. I just wanted you to keep repeating yourself. All right. And so what about for graph 2? I go over 1 and I'm going up.
3.
And then I go over 1 and I go up.
3.
And then I go over 1 and I go up.
3.
Perfect. Now we're starting to get in there. Now we're getting it. All right. So for the graph of y equals 3x, what does the point 3 to 9 represent in that story? What would that represent?
Y'all gonna say it?
Miranda, do you know? What does 3 to 9 represent in graph 2?
I think everybody's confused. Yeah, you gotta just unmute your mic. Y'all gotta just unmute your mic. Can I say it?
Go ahead, Jacaden. Help her out.
Is it 3 blue and 9 yellow?
Perfect job, Jacaden. Perfect job. So using what Jacaden just said, Miranda, can you tell us what the point 1 to 3 represents?
Miranda blue help is come.
Shh. She's answering.
I'm a little confused.
You're a little confused? So Jacaden said 3 to 9 represents 3 cups of blue paint for 9 cups of yellow paint. So 1 to 3 would mean Roy Kia, can you help her out?
Say that again.
Can you help her out for the point 1 to 3, what it means? I think Roy Kia is falling asleep. Help her out, Jacaden.
You said 1 to 3?
Correct.
It's 1 cup of yellow paint and 3 cups. 1 cup of blue paint and 3 cups of yellow.
Perfect. All right. Can you restate what he said, Roy Kia?
She looks asleep.
I'm gonna call Roy Kia's house. There we go. 1 cup of blue and 3 cups of yellow. All right.
I'm not asleep.
All right. You look like it.
All right.
All right. Here we go. So, hey. Now we're going to page 4. All right. And this is going to kind of engage us a little bit further in these ideas, okay? So I want Mr. Chandler to read this for us, please. Starting right here, buddy.
All proportional relationships have common features. One key feature is the constant of proportionality, which you learned about in an early topic. In the paint scenario, the constant of proportionality is the numerical portion of the unit rate that maintains the correct shade of gray. Remember that a unit rate tells you the amount for 1 unit. In this case, it describes the amount of yellow paint you need for 1 cup of paint, blue paint.
All right. Read down there at that next part. What's it say?
Sorry, what'd you say?
It says right there below it. What does it say?
You can find the constant of proportionality in the graphs of proportional relationships. For this shade of green, the unit rate is 2 cups of yellow paint for every 1 cup of blue paint.
All right. So, what do we need to do looking at our book? Basically, what this is going to do is it's going to show us the key concept of constant proportionality. Right now, it's saying that y equals 2 times x, which is showing us that for every 1 cup of blue paint, there are how many cups of yellow?
One.
Think about it. For every 1 cup of blue, there are how many cups of
Two.
2? Good. All right. So it says, what do you notice about the constant of proportionality in the graph and the algebraic rule? What do we notice about this constant?
It's 2.
It's 2. And we know that every time we have 1 cup of blue paint, there are how many cups of yellow?
2 times.
Yeah. All right. Moving on. All right. Now the green paint in mixture 2 was different. It was 3. So looking at this one, what's similar about these two?
It's 3 times.
It's 3. That's right. All right, so it's showing us that we're multiplying by 2 on the number 1, and we're multiplying by number 3 on the right. Jamal, will you read what's in yellow in the bottom, please, sir?
We could describe the relationship any other way. We could say that the first mixture reached required twice as much yellow paint as blue paint, and we could say the second mixture requires 3 times as much yellow paint as blue paint.
All right. So let's see what number 4 has to say. Number 4 is showing us that 1 to 2 is the same as has the same constant there. It's showing us that y equals 2 times x. And then on number 2 graph, it's showing us what?
Mr. Martin, why is it like you trying to talk on the man?
Me?
Yeah, it's not like you doing something.
No, I'm not doing nothing. I think Isamian's eating some chips or something.
Mr. Martin,
That's
just like you sound.
weird. It's probably my nose is stopped up. That might be why.
It's talking clear, but it just sounds like you put your hand over your mouth. No, it was because you were like leaning back and your voice would start distancing away from you.
All right. Well, I'm gonna get a little closer. See if it works better. All right. So in this graph, what's happening? Roy Kia.
She's always laughing.
She ain't gonna laugh no more because she's gone. All right. Right here, it says in the graph, the y value when x equals 1 tells you the constant of proportionality. In the algebraic rules, the constant of proportionality is the coefficient of x. All right. So it's showing us that the unit rate is equal to what?
To the numbers of paint.
To the numbers that's being multiplied for our constant rate. But yes, I see what you're saying, Jamal. All right. So let's take a look at this. So it says, can you identify the constant of proportionality in the table of proportional relationship? In the table, the constant of proportionality is the quotient y divided by x. That's what we've been using. So it says in this scenario, y divided by x always simplifies to 3 over 1. So the constant is therefore what? Say it, Isamian. Not 1. Not 1.
Wait, say it in a different way, please.
What is the constant?
Okay, it's 3.
Yeah, it's 3. Because y equals k times
K
x.
times
And
X.
k is the constant. Ooh, what in the world?
You just do some monkey eyes.
Is it 3?
It is 3. Good job. All right. So,
Mr. Mark, where you see that table at? Mine don't look like that.
this right.
In our this was like page 67.
All right.
I did it.
Yeah, we just went back to it.
Yeah.
It took it back. All right, my bad.
All right. So, right now, what I want us to do is I want us to go to our activity sheet on question 6. Okay. So, I want you to complete question 6 right now. And so while you're doing that, I want you to think, is there a reason you would want to compare yellow per blue or blue per yellow? And how did the two graphs of green paint mixture number 1 compare? And how do the constants of proportionality compare? So that's what I want you working on right now is question number 6.
It got spaces. Yeah, you're going to put space. It's 1 space, and then 2, 1, and then 3 space, and then 4, 2, and then 5 space, and then 6, 3. Oh, it's backwards. Look at that jump. Look, Mr. Murray.
Yes.
So, Mr. Murray, we're working on this on page 71, right?
We are working on page 71. Yes, sir.
You're going to trick me because I was thinking this is backwards.
No, put it back up to the screen, Jamal. A little bit closer, a little bit closer, a little bit closer.
It's like backwards.
All right, I'm going to pull mine up, and we'll look at it on mine.
I'm still gonna fill it out. Cause it got 1 full row and then it got spaces on the next, on the 3rd row, on the blue paint. Why?
I hit the wrong button. There it is. All right, number 6. All right, so it says that there are 2 cups of yellow paint for 1. Okay. So that means we're going to have some half mixtures, right? So what do I multiply by 2 to make 1? What times 2 equals 1 whole?
0.5.
0.5. So put that in the calculator. 0.5 times 2 equals what?
1.
Yeah.
1. Is that in the process or just the cup?
So the process there would be 0.5 plus 0.5 or 0.5 times 2.
I feel like me, Jacory, and Jamar are the only people answering.
Yeah.
They know what you can.
All right. So what's happening here? I see what you're saying. X is here. Y is here.
That's what I'm saying. That's what I said. Cause they in a whole different spot. Yeah. Not only they.
Are they divided?
They switch the spots of blue paint and yellow paint, but they switch Y and X.
All right. So I know what's going on, guys. I know what's going on. Okay. So we would say 1 times 1/2. All right. 2 would be 2 times 1/2. 3 would be 3 times 1/2. Because it's half the size, right? Y is half the size. Is that right or wrong?
I honestly don't know.
Well, if you do 6 times 1/2, what do you get?
6 times 1/2.
Yeah.
5. Didn't it say 1/2?
In other words, what is half of 6?
Half of 6 is 3.
Correct. So half of x
3.
would equal y.
What?
So y would equal 1/2 of x. Let me explain. Every time, all we're doing is we're taking x and multiplying by 1/2 to figure out what y is. Because 1/2 of 2 is 1 whole. 1/2 of 4 is
2 holes.
2 wholes. Okay?
Oh, yeah.
Half of 5 is 2 point.
5.
Yeah.
Well, you ain't put no half thing for 5. I mean, I get
I know.
it. It's still confusing me about the top.
The whole purpose was to get you confused.
Oh, then they did a good job.
Yeah, the whole purpose was for you to see that we're working with a constant that is less than 1, and therefore y ends up being smaller instead of getting larger. Okay? So when we say how do the two graphs of green paint mixture 1 compare, like when we're working with this, what's going to happen when we're working with this graph? Because it wants us to do the cups of yellow paint to the cups of blue paint.
We're gonna put it halfway, I guess.
So so this is 0, 1, 2, 3, 4, 5. So the first one was 1x to 0.5, right? So if this is 1, where would 0.5 be? Would it be all the way to 1, or would it be halfway between 1 and 0?
Halfway.
Yeah, it'd be halfway. All right. The next one is 2 to 1. So I'm going over 2 and up 1. The next one was 3 to 1 point what?
To 1.5.
Good. Next one is 4 to what?
4 to 2.
Good. So what do you notice already? This is a what?
A line.
A straight line, right? And it's going to pass through the origin. So what type of relationship is this? It's proportional, all right? And we also know that since it's a proportional relationship, that our constant of proportionality is what? What is our constant of proportionality?
It's 1, huh? I mean, 1/2.
Yes, it's 1/2 because we take 1/2 and multiply it by x to get our y. Perfect job. Okay, so let's look and see if there's number 7. Number 7 is yours to do right now. All right? I want you to do this on your own. And while you're doing this on your own, I'm going to update our classwork in webster.agilemind.com because we also want to get that completed today. So I want everybody working on parts A, B, and C. And it says these representations show the relationship between blue paint and yellow paint for different shades of green. For each representation, determine the constant of proportionality and write an algebraic rule. Remember that the algebraic rule is always going to be written as y equals what times x?
Gotcha.
K.
Like,
Remember that K is the what?
constant.
The constant.
Constant.
Okay, so looking at these, what did you come up with, Haley, for part A, for your equation or your algebraic rule, what did you come up with? What was your constant of proportionality that you found, Haley? For part A.
I didn't get one yet.
Okay, well, let's look at this. It's going 1 to the right, and then it goes up how many times?
4.
Correct. So what does the constant of proportionality have to be?
1 cup of blue and 1 cup of yellow, 4 cups of yellow paint.
Correct. So that means that every time we go over 1, we're going up 4. All right, since that's the case, that means that the constant of proportionality has to equal what?
One to 4.
Not 1 to 4, but just
4.
Just 4, because we're multiplying by 4. So basically what we're doing is we're taking the cups of blue paint and multiplying by 4 to get the cups of yellow paint. So the yellow would equal what times the cups of blue paint?
I know I got.
Think about it. What do I multiply by if X is the cups of blue paint, what number do I multiply by X to figure out what my amount of yellow paint would be? We know that if X is 1, yellow is 4. We know if X is 2, yellow is 8. We know if X is 3, yellow is 12. So what are we multiplying each time?
4.
Great job. It is 4. Good. So that's what we should have. I didn't mean to go through my equal sign. So y equals 4 times x. All right. What did you get for this one on B? Deonte, did you do that one?
I was trying to, but I got lost somewhere.
All right. Does anybody have this one? Chris? Or Emma?
I got 2.
All right. So I'm looking at what's happening. If I go over 1, I'm going up how much? Am I going up a whole number or am I going up a half?
Half.
I'm going up a half each time, right?
Yes.
So what does my constant of proportionality have to be?
1 half.
1 half. All right. So if my constant's 1 half, what equation or what algebraic rule would I write?
K E.
What would y have to be equal to?
I want to say
Not 2. What are we multiplying by each time?
0.5.
0.5 or 1 half. Good. Because 1 times 1 half, 2 times 1 half, 3 times 1 half, 4 times 1 half, 5 times 1 half. All right. Part C. You should be noticing a pattern here. Right?
Yes, sir.
All right. That's what I'm looking for. All right. Part C. We're looking at a table. All right. So looking at this table, what are you noticing? What do you see, Reginald?
Can I help?
Nope. You've done good, Isamian. You just get to sit this one out. Emma, can you help him? What do you notice? Sarah, can you help? Jacaden said he can help. What do you notice, Jacaden?
So on the first one, it was 1/3. Damn.
1/3 or 2/3?
I mean, was it 2/3?
Look at it.
I said the first one.
Oh, I got you. The first one was 3. All right. This one was 1/2. I got what you're saying. I want you to look at this one.
All right.
What do you notice about every one of
They all
these?
2/3.
They are all 2/3, and they're doing y divided by x. And we know that y divided by x equals what?
2/3.
It does equal 2/3, but it also is our k. And we know k is equal to our what?
2/3.
Correct, or our constant, right? So what algebraic rule could we write for this? What would y be equal to? Look back at A and B if you need help.
Two.
I'm following you, Jamal. 2 over what?
2/3.
Perfect. Times what?
Times 4.
No. What have we been multiplying by?
Times 8.
Times x, because that represents the amount of blue. Okay? So that is 100% correct. So right now, for closing, what could we do if we had a constant of proportionality that was 5? What would happen every time? If we had a constant of proportionality of 5, what would happen on a graph? Yeah, it'd go up 5 every time we move 1 to the what?
Right.
Great job. All right, so I want you to do our guided practice questions 1 through 4. So I'm going to go ahead and fix this real quick. And I want you to go into that on your Agile Mind. So go ahead and log into Agile Mind. I was supposed to click guided practice. So I got that fixed for you. All right. So go ahead and log into your Agile Mind at webster.agilemind.com and you can complete that work. Go ahead, Raziah. So that's going to conclude our day. So make sure you're doing your guided practice right now. I will see y'all tomorrow.